Hi everyone, welcome back. Today we're doing Truncate Sentence. We're given a sentence where a sentence is a list of words that are separated by a single space with no leading or trailing spaces. And each of the words consists of only uppercase and lowercase letters, no punctuations. So for example, hello world is a string, hello is a string, and hello world are all, sorry, not strings, but sentences. So in this case, you're given this sentence s and an integer k. And we want to truncate s such that it contains only the first k words and return s after truncating it. So for example, if we're given hello, how are you contestant, then in this case, if we take the first four words, we will get hello, how are you. For the second example, we are given 7 words in this case. So if we take the first 4 words, it will be what is the solution. And for the final example, if we take the first 5 words, it would just be the same as itself. For this sentence given to us, it will range from 1 character to 500 characters inside this string object. And k is in the range I to the number of words in s. S will contain only lowercase and uppercase English letters and spaces, and the words in S are separated by a single space. Finally, there are no leading or trailing spaces. So it's really pretty clean. So one way to do it, which is arguably one of the most efficient ways, is to iterate through S character by character, counting the number of spaces. And the number of spaces that we found thus far would be equal to how many words we have seen thus far. So if we count the number of spaces, then we can pretty much tell that this is the end of the sentence that contains all words. The final space that we count, of course, will not be included inside the sentence. So that is quite hard to demonstrate in words. So let's try to trace it out with a simple example. So let's define a number of words, integer, and this will indicate the number of words we have found thus far. We will increment this whenever we encounter a space. So we will also define an n index. This will represent the end of the sentence exclusive of it. So I will get into exactly what I mean by that in a bit. So as we'll be using this n index, there's no need for us to define it here as the starting condition of the for loop. So we will just say continue this for loop as long as this n index is less than s length. And after every iteration, we will increment n index by 1. So using this n index, we can get the current char. So current char equals to s.charAt n index. And if current char is equals to a space character, then what this means is we have just found one word. So let's increment number of words by 1. And if number of words is equals to k, then what this means is, okay, actually, yeah, in this case, character is not an object, so this is fine. We don't have to use equals. So if number of words is equals to k, then we can break. And we can use this n index over here to slice this string over here. So the final result would be s substring. The first parameter is the starting index, and the second parameter is the n exclusive of it. So if you pass in 9, then we will slice the characters from index 0 to index 8 instead. And thinking about it, this is perfect because once we reach the final space, then this n index would be pointing at that final space. So exclusive of that, if we specify this as the end of the substring, then it's perfect. We are getting the character just before this space over here. It might be a little hard to visualize this, so let's trace this out with a simple example. So let's use hello, how are you contestant like this. So number of words will be 0, n index will be 0, and at this point n index is equals to 0. the current character at position 0 would be h. So current char h. And over here, this is not a space, so we continue. Index 1 will be E, nothing happens. Index 2 will be L, will be nothing happens. Index 3 will be L as well. And index 4 will be O. Index 5 would be a space. And over here, we will finally hit this if branch over here. So at this point, we will increment number of words by 1. So now we move on. 6 H, 7 O, 8 W, 9 space. So we increment it again. 10 A, 11 R, 12 E, 13 space. So we found another word again. So we increment this again. And finally 14 will be Y, 15 will be O, 16 will be U, and 17 will be a space again. And we increment number of words to 4. At this point, we will hit line 14 because number of words is indeed equals to 4, and we will break the loop. So our end index will be 17. So what this means is we will take the characters from index 0 to 16. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So pretty much this. So this would give us this string like this. So it looks great. This is a pretty good run through of this algorithm. So let's run this against some test cases. And this passes, and let's submit this. Okay, and this works. So let's go through the time complexity. In this case, we will be iterating through up to, let's say, if we let n to be the number of characters in S. In the worst case scenario, if k is a very high number, up to the maximum number of words found in S, then this time complexity will be O(n). So at this point but in this case, O(n) is not really a fair, comparison of the time complexity here because we are terminating it early. So another way to express it is if we let k to be the number of words, then our algorithm will be OK. And if we let m to be the number of characters in each word, we can express this to be OKM. So in this case, it would just be pretty much OKM because we will terminate early over here. But it's also fine for you to mention that it is ON. And in this case, for the final part here, we'll be iterating through the string to get a substring of that. So similarly, the operation to iterate through S to get the characters from 0 to n index would also be OKM, or if you like, you can express it as ON. So in summary, the time complexity is O2km or O2n. But if you remove the coefficients, it will either be OKM or ON. So that's pretty much it. Let's remove the workings and let's look at the space complexity. So for these two variables here, they're going to use constant memory. It doesn't scale with respect to n, k, or m. And over here, we are reusing n index over here, so that's fine. Current char is also reused, so that is constant memory. And the only thing that's going to scale with respect to k, m, or n would be this expression over here on line 27. So this would be OKM if you like to express it with number of words or number of characters, or it would be ON if you choose to use n to be the number of characters. So in summary, this is OKM or ON. So that's pretty much it for this question. I hope that this was a clear explanation. If you like it, please give us a like and subscribe, and we will see you in the next video.